Hiya, welcome to my third TouchDesigner tutorial, and today I'm going to show you how to make this rain with puddles that are generated using Vertex Displacement and a bit of GLSL. What can I do? Let me show you how all of this works. So what I've got is this geo, or basically a tox, that has these settings on it, so I can control my rain in different ways. I've got gravity, so I can speed the rain up, I'll slow it down, I can have it nice and slow. If I reduce the displacement here to 10, you can see that the raindrops actually coincide with where the puddles hit, which is what I wanted when I was making this thing. We can change how much displacement happens on the puddles. If you want something a bit more extreme, you can get that. And what else can I show you? This can be scaled. The rain will scale back in if I reset this and change the speed of the rain a bit. Yeah, so it's all quite dynamic. I can bring this back up. We can change the height of the rain as well and where it falls from, and we can change the surface here as well. And this will keep working and running at 60 FPS because it's just mostly on the GPU. The rain's on the GPU and the displacement is as well, so there's not a great deal of CPU stuff going on. I think this main bit here is to do with the render inside of here. So, oh yeah, and the gravity works in all directions as well, so you can have that sideways rain that we definitely get here in Scotland. So, I'll show you the inside of this tox. We won't bother with all of the wiring and stuff in this video, you know, this hooking up of parameters and stuff, not to the point where we've got a finished tox. I'll just give you the guts of it. But the core is these two parts, a points gen and a water gen, or puddle gen, if you will. So the points gen is creating rain. I'll show you here, like this. And we can see that on OBS maybe. But what's happening is we've got two noises, one to generate where the rain starts from, and then another to offset the raindrops, you know, create birth times basically, so you get this nice rain-like randomization. All that then runs off the back of this feedback loop with some GLSL in the middle, and the output of this is, yeah, our rain, and then also a heat map, which is the locations of where our puddles will be on our water surface. So then our puddle gen takes that heat map, which is over here, and generates some puddles using instancing. So you can see here, this is where all the puddles will be. And then I put a camera on top of that, an orthographic camera, I've been trying to say that, over the top. And then we can use this image here of all of these different circles appearing to generate some puddles using another feedback loop. And we end up with something like this. And then from that, we can generate a height map and a normal map, which is difficult to see, and a color map. And then we run those into a PBR and use Vertex Displacement here with a display scale on a grid. And then we've got another geo here with our rain rendered using a line material. And then the outcome is this. So what I'm going to do is drag this over here so that I can reference it, namely the bit of GLSL that I need, so I don't forget that. And then we're going to just kick off making the project, really. So the first thing I'm going to do, just because we need it, is create the usual render setup, which will only take a second. So I've got a render top, 1920 by, goodness me, 1080. And then we'll need a camera and a light. And I'm going to pair up my light with my camera. I'm also going to make a look at, just because I really like this way of doing things, just have the camera always focused on something. So I'll have the light and the camera both look at those. And what else do I need to do? I think that's it. And I'm just going to tilt this up by 1. Okay, make a null and make the old RGB key laziness to put a black background on, and then show this. Okay, so got a render setup. What do we need now? We need to create some rain. So let's make a noise, and let's give this a null all the way over here, and we'll call this what we call this, rain points. And we will want to instance that rain, so maybe we'll just do that now. Let's change some settings on the noise first. So what do we need? We need color, because we need RGB XYZ values for that. We should change this to RGB 32-bit, RGBA 32-bit float, and let's bring our offset down to 0 so our rain is in the center of our view. Is there anything else on here I need to change right now? I'm not sure, but we'll find out soon enough. So that's enough to let us render something. So then let's go here and use an add SOP and a convert SOP to create our rain. So on the add SOP, we want to just tick add points, and that'll make 1 point. And then in our convert, we want to convert them to that point to a particle per point. And then make a geo, and then make a line mat here, and put that on our geo. Let's change the name of this to geo rain, and on our line mat we'll want to draw points like this. So there we go, we've got 1 point, amazing. So in our geo here, let's go to the instancing tab and drag rain points onto the translate and do RGB. Okay, so we've got lots of points, amazing. That's what we want. So let's change some values here now. Let's make a constant for our things that we want to change with rain, whatever you want to call that. And I'll make a null here, and we'll call this null params will do. And our first one is going to be rain density, and let's set this to 10. So this will be just how much rain there is, how many raindrops there are, and we'll use that as our resolution for our noise here. So just drag that onto the resolution parameter there. So at the minute we've got rain all over the place, but we're going to pretend that rain falls from a flat surface. So we're going to get rid of the Y information in here, so that we just end up with a bunch of points that are all on one level, and then we can have them fall down. So the way to do that is just to use a math top and set its G value range from 0 to 1 to 0 to 0, and that'll give us a nice flat plane there. And then the other thing we can do now is use a point transform, and we can change the height of our rain. So we can do that. We'll make another value here and call this rain Y, and we'll set this to 2. And then we can drag that onto our point transform in the Y, oh god, in the Y translate parameter here. And that's set it up to 2, which is maybe too high because my camera can't see it. Maybe I'll just zoom out a bit. Oh, no. Okay, well, whatever, tilt you up a bit. Do we need to see it? I don't know. Well, let's bring it down to 1 for now. And that's fine. There we go. Lovely. What else do I need here? Let me just check what parameters I have going on. Let me see. So, oh yeah, we're going to want to change the scale. Remember how the rain can go outwards and the floor can go outwards? We can leverage this point transform for that. So we can use the X and the Z to spread the rain out. And we'll do that by making another constant variable here. And we'll call this rain scale. And we'll go 2. And then we can drop this onto X and Z. Okay, so that's the top of our rain set up, which is nice. What else are we going to need here? So we're also going to need, as our rain falls, we don't want it all to fall at the same time. We want it to kind of one drop to go and then another drop and another drop and another drop. And the way we can do that is just by having some value that we count up to before we let the droplet go. And we can generate those timeouts just using a noise. So what I'm going to do is just copy this noise here, because that leaves this hooked up. And then I'm instead going to change it to monochrome. Put the offset back to 0.5, because this will now generate values between 0 and 1, which is what I want, especially if I turn this harmonic gain, spread and harmonics down. You'll see now if I chop to top this and then show all of it, full image. Oh, I'll need a shuffle. 1 second. I think this is worth demonstrating because this really bamboozled me for a while. So you'll see all of the RGB values are between 0 and 1, which is what we want. So now we can use that as our countdown value. And then let's put this here. Oh, we'll need another null here as well. So let's create 2 nulls, and this one will be p start, because this is where our rain starts from, and this will be births, p birth. And we can increase the births because we're just using values between 0 and 1. We can add a math top here, and then in the range just change this to something like 0 to 7. And now, you know, we can vary our births basically just by moving this number. Okay, so I think that's everything we need to actually get our feedback loop set up. So what do we need now? Let's create a GLSL multi, and we're going to give it 3 things. We're going to give it where our points start from, our births, and then we're also going to give it a feedback to keep the rain moving down, and we'll add that in a second. So, oh, my cat's coming to visit. No, she's not. She's gone over there. Okay. So what do we need to do here first? Let's get our rain moving. So let's, on this panel here on the GLSL multi under vectors, we're going to need 3 different things. We're going to need the floor height. So this is where our rain will intersect with the floor, so we know when to generate a puddle or not. We're also going to need a step, which is just to control the speed of our whole simulation. You can set this to just 1 over 60. Sorry, 1 second. 1 over 60 like this, because we're running at 60 frames a second. And then we're also going to need a vector for our gravity called uGravity. And we can set all of this to 0 and maybe set this one to -1. So we can see some movement when we get into the GLSL portion of this here. Yeah, let me bring up the code here because I'm going to forget. Okay, I'll bring up an editor, and then if I bring this here and this here, great. Is this going to do me over? No. Amazing. Right, so we need to bring in these 2 different textures in GLSL, and we'll do that using this method here that they've handily put in the generated code. So we'll do, first one will be p start, and we can see here it's using 0 on the inputs, which is this one here, and then it'll go 1 and 2 because we're going to need 3 in total. So we've got p start, and we've got p birth, and then we're also going to have a feedback loop in a second, which will bring in our actual point, which we'll do. I'm just going to copy this line here, texture, so this will be 1, 2, yeah, like this, and we'll output our point. Okay, so this is broken at the minute, but it will work in a moment. So what do we need now? Let's bring in a feedback. and hook our feedback up to a keyboard input so we can just quickly reset it. Grab this and put it on the reset pulse, and then we can put our P start in here and drop this into the third location on our GLSL, and you can see now the points have come back because the feedback is, its initial state is our points. Then we're also going to want to make a little null here just to then feed into our feedback, so just drag that onto the top of there. So now I can reset this. Obviously nothing's happening at the minute because we're not doing anything in our code to animate the rain. So let's do that. What do we need to do first? So to get our rain moving, we can just do point plus equals gravity, ugravity dot xyz, because this is a sorry, this is a vec4 and this is a vec3, so we'll need xyz here like this. Point xyz plus equals gravity xyz, and that will do something broken. Oh yeah, I need to define it, don't I? Of course I do. So up the top here, we need to bring in those vectors that we created. Let me just go here so we can see them. So we've got gravity, u-step, and floor height. So floor height is float. U floor height. And we're going to want to actually set that u floor height to something that we make here. So we'll put that in our constants, u floor height, and we'll keep it at 0 for now because that's where we've got our, that makes sense for our floor. On our GLSL multi, we'll want to drag floor height into here like this. So now that's set to 0. Lovely. So we need one for floor height. We need a uniform float u step for our simulation speed, and then we need a uniform vec3 u gravity, and that'll bring in these values here. Okay, so what have we got now? Yeah, there we go. Our rain falls really, really fast. Zoom, 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 zoom. Down there like that, so it's amazing sound effects. But if we times it with our u-step, then we'll get a much more sensible simulation speed. There we go. So there goes our rain off into infinity. Because all we're doing on each frame is adding -1 to the y component of our point. So if I can, because we're using this full vector here, we can also change the direction of the rain. So if I do -1, then it'll go in a diagonal direction like this. So we've got sort of basic gravity going on here. So that's our rain falling, brilliant. But we don't want our rain to fall into infinity. We want, when it hits the floor, for it to jump back up to the top of the sky, so that we get this infinite rainfall simulation instead of just off into infinity. I hit my nose as I was doing that gesture. Right, so to do that, we need to know if we've hit the floor. So we can ask if our point y is less than or equal to our floor height. So if it's gone to the floor level or below, then reset it back to its original start point, which is this P start here. So we can go point equals P start. And now our rain, when it hits the floor, will jump back to the top. So the thing we're missing at the moment is this variance. They all just fall at the same rate because they all start at the same time. So we can use our births noise here that we've created to jitter those starts. And we can, so what we want to do is, right now we've got an image that has RGBA inside of it. And we're not using this A channel at the moment for anything. So what we can do is use this to store a number that as it reaches, that we can add to. So it'll start at 0. and we can add to it until it reaches 1, and then when it reaches 1 we'll allow the raindrop to animate. So the first thing we need to do is set this alpha to 0 all the time, so that's the initial start state. We can do that on the noise here if we go to the output and set the alpha to 0, and then we can use our births here to count up inside of that channel. So the way to do that is to go if point.w, which is the alpha channel. We could also use A, but as I've used XYZ here, I just thought I'd stick to the convention of W. If W is greater than or equal to our pbirth dot x, because they're all the same, it's just a monochrome image. So if this value has reached the value we've got in our births texture, then allow it to animate. So we put this line of code in here. So if I save that right now, nothing will animate, and that's because we're not adding to this value here. But we can do that easily by going point W plus equals, and we can just use the uStep value like this to add up. So now if I reset this, you can see the rain will eventually start to fall in a sort of randomized and natural rain looking way like this. So that's cool, isn't it? So now we've got rain, which I'm quite happy about. The last thing we need to do in this shader, not shader, it's just a GLSL multi thing. I guess it is a pixel shader, yeah. Why not? It said it at the top of the file. What do we need to do now? We need to generate a texture that shows where our puddles should appear, that stores the locations of when each raindrop hits the floor. So we can do that by going to our GLSL multi, and somewhere on here there is a number of color buffers. And if we change this to 2, then we can start to output a new texture. If we go to the top of here, we can see we've got outvec4 frag color, which is the first color buffer. We can copy this and change this to something like puddle map, and then we can start to write to this every time we hit the floor. So here, where we go, have we hit the floor, we can go puddle map equals, and then use this TD swizzle, output swizzle line here to output our point to that texture. So that's now going out, and we can grab that texture by using a render select, drag our GLSL multi on top, and there we go. It's got the buffer index to 1. If I set this to 0, you see our other texture, our other output, which is frag color. But we change this to 1, then we get our hit map. So now this is just, I think if I do, yeah, you won't be able to see it on OBS, but there's points appearing there at the level where a puddle should be. So we can use that now for instancing to create puddles. Let's change this to puddle points. Okay, so we've got rain and we've got puddle data. Amazing. The next thing we need to do then is generate the texture for our water displacement. So let's do that. Let's make a base, because we're going to need to make another render network, and I don't want it to interfere with this one. So let's just keep it enclosed here. We'll call this puddle gen. I can also get rid of this now, give us more space. Call this puddle gen. It's going to bring in the top, which is our puddle data. Bring this in here, and then we can instance this using, so we're going to instance some circles to use for our puddles. I'm going to stick a transform in here. So we've got a circle sop, and a transform, and a geo. Let's make our circle ZX plane. Let's change the transform of our circle to 0.1 for now. It might need to be a lot smaller. And we can change our divisions to like 10 or something. Then on our instance tab, let's drag our puddle data on and do A, R, G, B. So now, hopefully, yeah, there we go. We've got Puddles instancing. The reason I've put this A here is if I get rid of it, you'll see we'll always have this one in the middle. And basically there's a... For every pixel in here, they're all set to 0, including the alpha. So what you're seeing here is all of those pixels in there that are 0. But if the alpha is also set to 0, we can use it as an active parameter here. So if I do that, it'll turn them off, if that makes sense. Because their alpha is 0, we won't render them. Yeah. It's just one of these things with using textures. So let's render this out. We're going to need a render top. And let's set this to quite a good resolution, 2048 by 2048. And then make a camera and an ambient light, because we don't need to worry about any shading or anything like that, because we're just using it to generate a puddle image. If we set our camera to rotation -90 on the X and then bring its height up to something like 2, it won't matter because we're going to change this to orthographic now anyway. And then why can't we see anything? What's going on here? Have I got this right? Maybe this needs to be higher. No, -90 here, 5 there. Oh, orthographic width. No? What am I missing? What's going on? Let's have a look at our camera. Oh, there we go. Okay. What have I stuffed up here? Let's reset this. Apologies. What do I have in my other thing? Hold music, while I figure this out. Yeah, -92 or 0. Okay, so -90, 2. There we go. Lovely. And this ortho width will be the same as our floor scale. So what we can do is open a floating network here and take this rain scale, and use this as our ortho width here. So then when we change our rain scale value, the camera will spread out as well. So we get we can capture the rest of the puddles. So now we've got that, we've got our circles, we can start to create some puddles from this. So let's make a feedback and make a comp. I think I'm just using over actually. Over like this. Might need to swap those around. Let's make a key in chop with the value of 2, so I can reset this if I need to. There, so that's that, and then I'll need a null here and drag that on top of the feedback. Okay, so now we've got a build up of puddles. Amazing. Does this need to be on top of here? Does this need to be the other way around? I'm not sure. We might have to figure that out. Right, so this is great, but it looks nothing like Puddles, does it? So let's get it looking like Puddles. We can do this. There's just this very neat trick where you can use an edge top inside of a feedback loop and you'll get this stuff. And then you can use a blur here to start to dissolve some of that noise like this. So I can keep resetting this here. And we'll just need to change this filter size up to something like 11. and maybe change the sample step a bit. So there we go, we've got something puddle looking. You can also play around with the edge settings as well and change the sample step here if we want to get more waves coming out of our puddles. That looks quite cool actually, but maybe I'll bring it down to 1.2. We'll see how we go with that. So that's the ripples for our puddles made, and now all we need to do is create a color map, a normal map, and a height map to put on a grid SOP, and then we're basically there. So let's first make our height map. So we'll use a monochrome top and change this to pixel format 32-bit mono. So that's a height map. We'll use an out here. Oh, I've done an outside. Use an out. And yeah, so that's our height map. I might just rename that to out height. Yes. Then from here, let's make a null. And what do we need to make here? A color map of some kind. Yes. Let's make a noise. And let's make a ramp. Just to make something watery looking, and a lookup. And we'll plug the noise into the lookup and the ramp in, and now pick some watery colors on here like this, and like, I don't know, like this. Kind of looks like water. Maybe we'll up the period of this a bit. Yeah. And animate it. So if we go to common and transform, and on the Z do abs time.seconds times 0.1 there. So we've got some nice animated noise. I might just make this look a bit more obvious. That's not helping. That's kind of helping. It's watery enough. It's good enough. Okay. So what do we need to do now? I need an over here, because what I'm going to do is put the puddles over our texture like this, because this will make a nice normal map. So we can just from that do normal, and then we've got our normal map, and we can out that as well. Out normal, and then we've got our color map here, so we can do just I can just do a straight out actually. Where is it? There. Out color. Right, so that's our 3 maps that we need to finalize this project really. Let's have a look now. So we've got our rain here generating, and we're going to want to make another geo. So everything's a bit messy, but we'll just drag this over. Bring this one over here. Let's make another little render geo setup for this. So we'll make a grid SOP, which will be our floor. Make it ZX plane. Keep everything size 1, blah blah blah. Let's do it 1000 by 1000. This is gonna cause my computer to stall momentarily. There we go. And then I don't think I need anything else on there. Just a null. Didn't even need that really. Geo. So there's our floor. We'll want to have the scale of our floor or water surface the same as our rain. So we can do that on this geo scale. Don't do it on the SOPs, because if we do it here, then it's all happening on the GPU. So over here, let's drag rain scale over onto our uniform scale for our floor, water, whatever. And then we need a PBR here, or you can use a Fong, but I'm using a PBR just because they look nice. PBR material on there, and we'll need an environment light, which I can make very quickly. Just chuck an environment light up here with a movie file in top. Grab the nice cloudy ocean and drop that on there. Great. So that's our water surface. Let's get our 3 images out of here. That's our height map. And our normal, so we'll call this color, normal, and height. Then on our PBR, we need to go to our maps and drag on color and drag on normal, and then do enable height map, bring the parallax scale down to 0 because it'll make it look horrible, and then the height map on there, displace vertices, midpoint to 0, and the display scale to something that looks sensible, maybe 0.4 for now until we can see what's going on. I think we'll need to, on our PBR, go to RGB here and bring the roughness down to something like this. And then, oh, we need tangents, don't we? So see here, this is complaining. We'll need tangents on our grid because we're bump mapping. So we've got attribute create here, create tangents, and that should solve that problem. This displace is still looking a bit crazy. We'll fix that in a second. I'm just going to bring us in a bit so we can appreciate what we've got. Okay. Might bring the look up a tiny bit as well so we can see. Right, so we've got some pretty gnarly looking puddles just now. Is there anything else we need to change on here? Let me think. On the maps, oh yeah, if you go to your height map and click these two little arrows and change the extends to 0, it'll just tidy things up around the edges with this displacement. Okay, what do we need to do to fix this then? So let's bring our displace right down to some tiny value. There we go. So 0.01. And then our puddles still look a bit not very real just now. And I think we can fix that. We'll keep the bump mapping the same. We can fix that by playing around with our feedback and edge stuff just to tidy that up a little bit. Let's have a look what we've got. So I might get rid of this sample step here for now, just so we get something a bit more puddle looking. Yeah, that's looking better. It's still looking a bit strange around the puddles. I think it's this normal map looks a bit intense. Let's bring the sample step down on the blur. Oh, there we go. Oh, that does look nice though. Look at that. It's lovely. Let's just bring this back up for now. What do I need to do here? Let's reset the rain, reset the floor. We've just got something not quite right. Let me figure out what it is. Bump scale down a bit. Or maybe that's all we need to do. It's just a bump scale down. It's fine. Let me just check my other project here. Double check I've not missed anything. Yeah, the displace is the same. And the bump scale is higher. But I think it's probably to do with either the scale we're doing things. Oh yeah, so it could be this. So if I do bump mapping back to 1, and in our puddle gen, change the scale of our circles down to something like 0.05. Hopefully that fixes things a bit. It's a slight improvement. But yeah, maybe play around with, let's see what we've got here. Yeah, so they're quite big spots on there. So we can make them smaller even. And I think this should tidy things up. Yeah, so now we've got very, very small spots. There we go. So that's the bump mapping at 1. And we've got our rain looking quite nice there. And so that's kind of the gist of it really. That's everything. We can stop the rain. We can reset the floor using 1 and 2. We can make our rain look a bit more like rain in the line mat here. We change the point size a bit. You could change the color. We've got our settings here, so we could change the floor height. And this should just not work. Why does that not work? Oh, I think I need to hook it up to this puddle here. So I drag this onto here. And then change this now. Yeah, so there we go. That still works all the way down there or up here. and then we can scale things out or in, and we can change the height of our rain, can bring it down. Oh, see, so we're seeing our start points there, so let's bring it back up to 1. And we can change our rain density to something like this. If we just hit 1 to reset that, then we get all of our rain coming in, which looks nice, doesn't it? I think here on this noise for our bursts, if we up the period a bit to something like 10, we should get a bit more of a natural fall. Yeah, there we go, when things come in, because it was going a bit like this. And I think this looks a lot better. We are not quite picking up points on the edges here, and I think there's something gone slightly awry, but we can fix that. So we've got scale 2 there. Did we hook up the ortho width properly? We did. What's going on here then? Okay, so I had to quickly pause because that was driving me crazy. The problem was inside the puddle gen here, the camera, because I'd moved around in this viewport, it had changed some settings on the near, these two settings, the near and far, so it was breaking the render. I've also set the point size here on this transform for the circles to 0.01, and now we've got our rain looking nice and the points are aligning properly. So there we go, that was the issue there. So now, yeah, we can change our rain density back up to something awesome like this. There we go, looking a bit more rainy. And we can change our gravity on our GLSL multi to rain speed, something like this. We can change this right up to like 50, reset it. There we go, lovely rain. So that's it. That's the general gist of this rain thing. I don't know, there's much more I can show you. I was just trying to play around with that. Yeah, that's the lot. So what else is there on top of this? So yeah, all I did was then take these settings and apply them to a tox. But yeah, I think we're done. So what I'll do is I'll upload this to Patreon, and the project file. And yeah, if you would like to join that, it's over here. It's patreon.com/those eyes. I'm just getting started on it, so there's only 2 other tutorials on there at the minute, but any support is thoroughly welcome. I might change the display scale on this a bit more, make this a bit lower, because it's just, oh, I've gone too far. Bring this down to here like this. And then I quite liked those big puddles that we had before as well, with this edge. Do this. Yeah, I like the ripples on that. If we just get the density back down to something like 10. Yeah, I love this. The big puddles. It's good. Good fun. Also, if you would like to, please do follow me on Instagram. I am those eyes, oh my god, on Insta. Here's the original rain thing. It started with sometime last year, November last year. Okay, so I think that's everything. Thank you very much for watching. I hope that wasn't too shambolic and was helpful in making some nice rain in TouchDesigner. So thanks very much, and I'll see you again soon.